we wanted to try to sort of lay out how smart machines fit into the world here. So I'll start drawing some pictures here. All of this starts with a piece of hardware. Right? It's a pizza box probably sitting inside of a rack somewhere in a colo, somewhere very, very far away that's got good, cheap electricity and good cooling. On top of that, you're going to have some kind of an operating system. Now, in the past, that might have been a Linux or Windows. We'll walk through a couple different models to see how it is that we got to smart machines. And then on top of that, the whole reason that you put your infrastructure in place, which is you have some application that you want to have running, and that's going to do something, right? I mean, none of this does anything. It just allows the application to actually do something. Right? Your business logic is all up here. So this is just useless. Well, useless is a little strong. This is a precondition for you being successful. But no matter how good or bad that is, as long as it lets me get my job done, I'm happy. You've got your application, and then you have load on that application. It's going to look something like this. And you have two options when you build your application. You say, I want to be able to survive when there's this much load on my application. Or you say, I don't want to be able to survive when I build the application. Now, anybody who wants to keep their job makes sure that their application is going to survive at that point, right? This is when the most orders are coming in because you just got promoted on Slashdot. This is, there I dated myself, right? This is when you got featured on American Idol because somebody was wearing your shoes. Whatever it is that made you suddenly popular. So this is all kinds of people who would want to be using your service that wouldn't normally use your service. And so you make sure that you're able to sustain that, right? You have hardware available for that. And what that means is that, on average, you're actually using very little of your hardware. So on this, maybe on average, you're using 6% of your hardware. We found traditional architectures, that's about what they tend to be using. 6% of CPU on an average basis, most of the memory available as well. Well, one of the solutions that people have come up with is, we'll take this space and we'll try to divide the hardware into pieces, and then we'll put different people onto it, right? So if in general they're going to use 6, and so they go ahead and use a virtual machine instead. So how does a virtual machine work? Okay, so virtual machine starts with a piece of hardware. And then on top of that, there is a hypervisor, or KVM, or XVM. There's a bunch of different ways to do this. But the end goal is to have what looks like a piece of hardware running right here, and a whole bunch of those next to each other. Each of those is the beginning of a virtual machine. And what it actually has done is it's actually subdivided your real hardware and then bound the real hardware through the hypervisor to a virtual machine. And it's actually a one-to-one mapping. So you now have these virtual machines that have emulated hardware inside of the virtual machine. You had to consume some resources to put the hypervisor, and then you had to divide up your underlying hardware. And then on top of this, you have an operating system. So inside of here, you begin to have exactly the same architecture that we had a little bit bigger before. And then on top of that, you have an app. But what's really interesting about that is, by dividing up this hardware into these little pieces, you can have this one using some of the infrastructure, and this one using some of the infrastructure. And you can actually spread those across lots of different boxes. And so they can consume different pieces of the architecture. So you can pack more folks onto here. You can acknowledge that you're only going to use 6% of the architecture, so you can get a lot more utilization. The other thing that you can do is, because you're not loading your operating system and your application directly onto the hardware, you can automate creation of these instances. Right? So that's the exciting thing that happened with the cloud, was that I can just log into a website and I can say, give me a VirtualBox. Boom, give it to me. I can say, tear it down. And I can start selling those as separate instances. So I can have them for 5 minutes or 10 minutes, and I can tear them down. And then they can sell it to somebody else after that. So there's not a lot of the cost associated with provisioning. But there's a lot of overhead here, right? We've added in a hypervisor. This is still same old boring operating system that I was always using. So this operating system isn't any smarter about using resources. It's also not any easier for me to manage. It's the same old operating system that I've always been using. It's also lots of instances of an operating system. Which means that the overall amount of code that's available to you is a lot smaller. So if you buy a virtual machine inside of a cloud product, maybe half of the space, maybe 25% of your space is going to have to be used for that operating system. So the smart machine starts with exactly the same setup that we had, right? You have an application that's very, very spiky. You have a piece of hardware. And the question is, what are you going to put on that hardware? You know that you want to get your application on there, but you have an intermediate step. So what we did is we took an operating system and made that operating system smart. In particular, focused on making it very, very efficient for running applications and very, very efficient for optimizing the performance of those applications and then for virtualizing those applications. So this model looks pretty similar to the virtual machine model that you saw just a second ago, but it's a little bit different. How is it different? Well, to start with, the only thing that's inside of this virtual machine is application code. Because the operating system is actually here, and it's being shared across the entire field of smart machines that have been created. So every one of these smart machines that's going to be running on top of the smart OS has access to the operating system. It's already readily available. It's being centrally managed. All the patching is being done for you. So you don't have to think about managing that when you're building your application or when you're putting your application code into it. Another thing is there's only one instance of it, so the efficiency is quite a bit higher. And then the last thing is, what we didn't do is what was done in the virtual machine world, which was break this into boxes and then put a replica of hardware up there. We didn't have to do that because all of the hardware is available to the smart OS at all the time. And so what we provide is the ability for an application to access the hardware, and in fact it can access the entire hardware. Not just a little piece of the hardware. So all of these different applications are going to be running, and one of them might be this pattern, where it's got these big spikes, and another one might be running and it has its big spikes at a different time. Right? Something along those lines. And so at this moment in time, the resources are all going to be going to A, and then a little bit later, the resources can all be going to B. And that's when we talk about bursting, right? We guarantee that A or B are able to get the resources, to run at sort of the mid-level, whatever resources are guaranteed. And then we also give them the ability to access those additional bursting resources. So they can grab all of the hardware, right? All of the CPU that's there, and really take advantage of that. And so that's the key, is that we then have these applications able to interact with more of the hardware. But it's more than that, right? It's not just bursting. It's also recognizing that one of the big constraints on the hardware is the ability to access I/O and how quickly disks write. And so we've done a ton of work inside of SmartOS to provide caching of I/O, right? And make it much more efficient and much faster for you to be able to interact with disk. We've done a ton of work on eliminating overhead associated with the operating system, making it much more efficient, optimizing for the particular hardware that it's running on. A lot of the things that are really around performance and stability and security. We've done a ton of work to make sure that these are isolated from one another, so you have a secure multi-tenant environment so that all those things can work well, even though you might have an application from a media company, an application from a bank running on the same box, completely isolated from one another, but have very different cycles, right? This might be in the evening when people come home and watch TV. This might be during the day when they're connecting and taking a look at a piece of email, right? So having those sort of counter-cyclical application cycles makes it possible to get more out of the hardware and more out of the compute resources that are there. So I mentioned at the very beginning, you get about 6% hardware utilization on a traditional application. On virtual machines, we've heard anywhere from 30 to 50%. We very consistently run at utilization levels well above 70%. So more resources being available to the applications where they can consume them and really take advantage of it. And so that's what's smart about it. The other thing, though, that we worry about and that we think a lot about is once you get beyond a single machine, how do you build these architectures, right? So it's not about how do I get the most out of one box, right? Almost nobody builds applications that can run on one box and then spends time thinking about architecture. That's like, a stick is not a piece of architecture. You need a lot of sticks before you get an architecture, right? You got to connect them together. And so what does an application look like? Well, an application might look like, maybe a monolithic application, right? It's just my app. More likely, though, as the application gets bigger, it's going to evolve into something that's an N-tier application. So you might have an app server. You might have a web tier. You might even get to a point where you have a database that's on a separate machine. So you can imagine sort of having 3 different machines like that. Maybe over time, it's going to get a little bit more, more complicated, more sophisticated. So you need to add in, another app server that's also connected into the database. And you need to do load balancing at your web tier. So those both go in there. You get multiple app servers. And so what we focus on is allowing people to build those architectures and automate them. And so underneath this fabric of an individual instance of a smart machine is what we call the smart data center. If I could spell, it would be smart data center. What the smart data center does is it provides an API for managing all of these different instances. So SmartOS connects in there. Some other piece of hardware will have on top of it an OS that will be connected into there. You might have a router if you've got a really sophisticated app, and that's going to get connected in there. We run a little agent on top of that router. And so you're able to write your application. You're able to manage your infrastructure, all using the smart data center. And so you could build these entire complex virtual environments with real topology, right? So you could have your web tier running here. You could have one app running there. You might have another one running on a different smart machine over here, your database running over here. And then you might have dynamic routing or a VLAN moving traffic back and forth based on where load is, right? So maybe you serve up this set of databases in Asia at a particular time of day, and then later you serve people in the US based on that kind of traffic, and you dynamically make those types of modifications. So that's what we're thinking about, is how do people automate provisioning, building, and managing those applications across all those different spaces. So we'll have multiple different applications. We have a sense based on what they've done in the past, when they're going to consume resources, what kind of resources they're going to consume. Maybe this one's very CPU intensive and this one is very disk intensive. We can start to make some of those sorts of trade-offs. What's really interesting is we can do some of that scheduling. The people who are constructing their application architectures can do some of that as well in the way they define their architectures. Where I get excited about it is when all of that sort of gets taken care of you in an automated fashion. And so that's the work that we're doing on the Smart Platform, so that rather than saying, here's a PHP application, it now needs more PHP, oh, and it needs more database, oh, and it needs to be connected into an additional load balancer, right? You can automate those things with a Smart Data Center. But what we'd rather do is say, more people connected to my app, and have the platform itself actually provide those new resources for you. So that's the work that we're doing with Smart Platform, is you just write it in JavaScript, and it scales. And it works really well because it's the same language that's going to be used to present that application in the browser. And so people are already familiar with it.